Classifying real numbers. Regions of the world can be categorized based on specific properties, such as political and administrative divisions. Using the graphic organizer, place the letter of each region in the rectangle you think it belongs. A. Pennsylvania. So Pennsylvania is a state in the United States. Hence, I'm going to place it in the state. B. Chicago is a city in Illinois. Hence, I'm going to place it in the cities category. Notice that the city is in the state. C. Los Angeles. So Los Angeles is a city in California, in the state of California. So I'm going to place the C here. D. Florida. So Florida is a state in the United States. So I'm going to place it under states. And finally, E, Upper West Side. So Upper West Side is a neighborhood in New York City. So I'm going to place it under neighborhoods. So notice here that North America is made up of United States, Mexico, and Canada. Those are the countries within North America. And then within those three countries, and depending which country you're looking at, so let's say we're looking at the United States, you have states within the United States, and you have cities within the states, and finally you have neighborhoods within the cities. So each group is a subgroup of the one that's bigger that it belongs to. So this is something that we're going to now apply to different types of numbers. So you can give a definition for what a United State is, what a state is, what a city is. Numbers are also classified into sets of numbers based on their properties, definition, but we're going to use the word properties. Numbers can belong to more than one set. Below are all the different types of real numbers. So to the left side, you have the set of all real numbers. So you can think of that as North America. And then you have different other types of numbers within it, which we're going to define and find examples of. So the definition for a natural number is all counting numbers starting from 1. Example, so think of when you're playing hide and seek, you start counting not from 0, but 1, 2, 3, and so forth. So those are natural numbers. Whole numbers are all natural numbers and 0. For example, same as above, but it also includes 0. Integers. So integers are all whole numbers and their negative opposites. All whole numbers and their negative opposites. So for example, here we have 0, 1, 2, 3, etc. Like the numbers above, and then we're going to add their negative opposites. -1, -2, -3, and so forth. Okay, so what are rational numbers? So rational numbers are all integers and numbers that can be expressed as a fraction or ratio of two integers. It includes terminating and repeating decimals. So all integers and numbers that can be expressed as a fraction ratio, which is the same thing, of two integers. It includes terminating and repeating decimals. For example, you have all the numbers above plus 3 divided by 2. There's a ton of examples here. A decimal, repeating decimals, terminating decimals, and so forth. And finally, irrational numbers. It's a number that is not rational. It includes decimals that never end. A number that is not. So if it doesn't fall under the category of a rational number, we can put it for now in the category of an irrational number. It includes decimals that never end. There are also other types of numbers, but for now we're just going to classify numbers as whether it's rational, and if it's not rational, then it is irrational. For example, the square root of question 1. Use the words below to label each section of the Venn diagram with the correct type of number. Then classify the real numbers accordingly. Try to only place 2 numbers in each set. You can place more numbers in each set. However, just to be more specific, it is possible to put all these numbers that you will see here in this table to place exactly 2 numbers in each set. Okay, so the set of numbers that we've covered are real, rational, irrational, integers, whole numbers, and natural numbers. And here are the numbers that we're going to try to classify and place in the Venn diagram below into this one. But first, we're going to label, using these words, the categories in the Venn diagram. So, the real numbers Venn diagram, here we go. Okay, so the whole box here is the set of real numbers. That is, both rational and irrational numbers fall under the category of real numbers. Then we have rational numbers, and irrational numbers. And then within the rational numbers, we start off learning about natural numbers. Natural numbers, the ones you use to count, 1, 2, etc. Then we have whole numbers. And the main difference between whole numbers and natural numbers is that whole numbers include 0. And then whole numbers and natural numbers are included in integers. And integers include all whole numbers, but they have the positive, negative, and 0. And finally, we have the rational number and irrational numbers over here. Okay, so now we're going to try to put in all the numbers that we see, that we have here in the table, and put them accordingly. So let's start off with the first one, 1. So 1 can go into natural. It can be also a whole number. It is an integer, and it is also a rational number. So I'm going to place it here. And you can actually place the 1 anywhere under rational, integer, whole, or natural. But because eventually you're going to move them around to try to fit 2 in each category, 1 can be placed there, but your answers can vary. So let's look at the next number, 0.46. So for sure that can't go natural, whole, or integer. It's going to go under rational number. So 0.46 because it's a decimal. And then the next number is 4 pi. So an irrational number, pi, multiplied any number of times will continue to be an irrational number or remain an irrational number. So we're going to place it under irrational number. The next one is 0. I'm going to place that under whole number. The next one is -3. So can't be natural or whole, but it includes positives and negatives, which is integer. Number 5, it is a natural number, whole number, etc. I'm going to place it under natural. The next number here is the square root of 9, which is equal to 3. So it can be either integer, whole, natural, or rational. I'm going to place it under whole. Then we have 2/3, which will equal a decimal number, a repeating decimal number. I'm going to place it under rational. Then we have 2. I'm going to place it under natural or whole, etc. But it can fall, the most basic form where you can start is at the natural. I'll place it there. And finally, the negative square root of 10. So 10 is not a perfect square, which means it will give us a continuous decimal, an irrational number that is also negative. So it shall go under irrational number. And here's just one way of organizing these numbers. You could place them differently, such as the 1 here could be placed and switched with this one. But this is just one way that you could have organized your numbers. And then there's the practice sheet. If you want, you can freeze it and try to complete it. But that is all for today's lesson. I hope you enjoyed it. Have a great day.